This flyover is located at Bmc Chowk, Jalandhar. Project was started in 2010 and finished on 15 July 2011. The approximate cost of project was 20 crore. This flyover carries 23% of traffic volume from Bmc Chowk. Maximum traffic comes from Kapurthala. Improvement Trust give contract to Public Works Department to construct this flyover. First, we analyze the failure, in which we discuss the types of failure, loading conditions of failure portion, and failure simulation. Then, what is the reason behind these types of failures? And what are the solutions for this? So, there are three types of failure. Longitudinal crack. This type of cracks are developed parallel to the centerline or lay-down direction of the road. These cracks develop throughout the thickness of the pavement. That means surface goes to subgrade, and these cracks are not load-related. Longitudinal cracks are caused due to differential volume change in subgrade, settlement of soil, or sliding of side slopes, but in this case, it is due to the bulging of retaining wall. Second, bulging of retaining wall. A retaining wall is a structure that is designed and constructed to resist the lateral pressure of soil, when there is a desired change in ground elevation, that exceeds the angle of repose of the soil. In the case of a flyover, the retaining wall is designed according to surcharge load due to traffic. Cause of failure. Bearing failure of soil. Excessive pore water development. Settlement of soil. Unexpected loads. And third is settlements. There are two settlements at ground level, first at near traffic light pier, and second is in between the abutment and first pier from the failure portion. These settlements are mainly caused due to consolidation of soil, improper compaction, unexpected loads. This is a cross-section of the Bmc flyover. At failure, in this type of construction, the load is transferred by compacting layers of soil to the desired height of flyover, and retaining walls are constructed on sides to retain the soil pressure and its position. So, the soil has to be properly compacted and dense before applying load on it. It looks safe enough, let allow the traffic to flow over the flyover. These arrows show the distribution of load. Big arrow tells major load. Similarly, the small arrow tells the minor load. So, the majority of the load is transferred by soil. If due to any reason, the density or properties of soil change, it will affect the loading condition, which may lead to failure of the structure. First, a simple crack is formed. Then, vibrations due to traffic, the crack starting to expand. When the rain comes, then the storm water is trying to infiltrate into the soil, which develops the pore water pressure. As we know, an increase in pore water pressure decreases the effective stress in soil, which decreases the bearing capacity of the soil, and due to continuous vibrations from traffic, the settlement of soil and subgrade occurs. Due to settlement, there is rotational stresses acting on the retaining wall. As we discussed earlier, if there is a change in density or properties of soil, this may lead to a structural failure. So, the same thing happens, settlement in soil and subgrade changes the loading condition. Due to this change, the majority of the load is transferred to the retaining wall. The retaining wall is not constructed to handle this type of load. So, this results bulging of the retaining wall. In this picture, these cracks show it fails due to excessive loading. That means the majority of the load is transferred by retaining wall. As bulging occurs, surrounding soil loses its position and density. Then, this forms a 40 to 50 meter long longitudinal crack. We also prepared a 3D model for that. According to us, there was two fault point. The first fault triggers the bulging, then due to bulging of retaining wall second fault happens. Lack of appropriate planning. Traffic volume has rapidly increased with the time of its construction. Due to this, vibrations due to traffic settlement of soil occurs. This means flyover was not ready for increasing loads due to an increase in traffic volume. Improper construction. Longitudinal cracks are formed when the density of subgrade and soil varies. That means improper compaction of soil or improper laying of pavements, improper maintenance. A similar crack was formed before this. They tried to maintain, but the crack continues to develop. Improper drainage. In this portion of the flyover, there are two ways to drain storm water. First by surface, and second through the drainage pipe in retaining wall. We think drainage pipe might be a reason, because there is only one pipe is provided at the bottom on each sides. That means if stormwater infiltrates through the surface, then the only way out is from the bottom. Restoring the bearing capacity by injecting this polymer. This polymer is a two-component, high-density, expanding thermoset polyurethane system. It was developed to be the ideal solution for void filling, lifting of settled pavement, stabilization and stiffening of weak soils, encapsulating and sealing buried infrastructure. This is environmentally inert, non-toxic, and resists underground water erosion or weakening due to its industry-leading hydrophobic properties.